Welcome to another interesting mathematics class. My name is AK Omoji. I am your mathematics friend and tutor. Today we'll be talking about quadratic equation, but specifically how to get a quadratic equation from given roots. By the end of this class, you should be able to form quadratic equations with given roots. Before we start thinking of how to find quadratic equations from given roots, let's first of all understand what the roots of a quadratic equation are. The roots of a quadratic equation are the solutions of that quadratic equation. Also, we say the roots are the zeros of that quadratic equation. To get the factors from the roots, what we need to do is to equate the roots to 0, as shown on the board. Now, let's go on to see how we can find the roots of quadratic equations. So how do we find the roots of a quadratic equation? To find the roots of quadratic equations, we can either decide to solve the quadratic equation using either the formula method, the factorization method, or the completing the square method. We can as well decide to use the graphical method, which shall be discussed in the next part of this topic. If you look at the graph on the right hand side, you will see that we have two lines, this line going down and this one. So we call this one the vertical line and then this one the horizontal line. Now the point where this curve cuts the x-axis are called our roots, and as you can see them here, the first root is -1 and the second root is 3. Now how do we find factors from these roots? To find the factors, what we need to do is to first take this x is equal to -1 and the next x is equal to 3, which are our roots. What we now do is to equate them to 0 as shown here. These steps shall be explained in detail later. Now that we know about the roots and how they can be found, let's now see how we can form quadratic equations from given roots. To form quadratic equations from given roots, the first thing we need to do is to convert the roots to factors. Take for instance what we have in this diagram. Remember, previously we had that x is equal to -3, right? To make this equal to 0, what we just need to do is to say x plus 3 is equal to -3 plus 3. This is just like saying add 3 to both sides. When I do this, I'll have x plus 3 is equal to 0. This is what we have here. If I repeat the same process, I'll get the other one to be x equal to -1. Now will become x plus 1 is equal to 0. That's what we have here. Our step 2 is to expand the factors, and we will learn about that as we proceed. Just to emphasize more on converting roots to factors, you can see that x equal to -3 was converted to this. X plus 3 is equal to 0. You can see also that x equal to -1 was converted to x plus 1 equal to 0. When we put them together, we have this equation up here, which is just a combination of these two, x plus 3 and then x plus 1, and we equated both to 0. When we expand them, we'll get this expression here, x squared plus 4x plus 3. Like I said earlier, we'll see how this is done as we move on. Now let's go on to try an example. Example 1. The roots or solutions to a quadratic equation are -2 and 3 respectively. Obtain the equation from which these roots were gotten. The first thing we need to do is to write down all that was given to us. And from the equation, we know that x is equal to -2 and also x is equal to 3. These are our roots. Next, convert the solutions or roots to factors. How do we do that? We simply say x equal to -2 now implies x plus 2 equal to -2 plus 2. What I just did was to add 2 to both sides. And then I'll get x plus 2 is equal to 0. This is my first factor. The second one is x equal to 3. That now implies that by subtracting 3 from both sides, we have x minus 3 is equal to 3 minus 3. That will now imply that we have x minus 3 is equal to 0. This is now our second factor. Next thing to do is to expand those factors we got. Remember, we got these factors from our last solving, right? X plus 2 and then x minus 3. These were the factors gotten previously. So let's expand them. But before we go to our expansion proper, let us learn how to do the expansion. To carry out the expansion, first of all, we need to multiply each term in the first bracket into the individual terms in the second bracket. Also, while doing that, you need to take note of the signs of the terms. How do we do that now? Let's start the expansion process. First, like I said, we multiply everything in the first bracket into individual items or terms in the second bracket. So we start by saying x times x. That will give us x squared. Next will be x times minus 3x. Notice that I'm including the sign in front of 3. So that will be x times minus 3x. It will give us minus 3x. Of course, you can read that as minus 3 times x. The next will be now to multiply 2 by x. This times this. Please note, the 2 has a positive in front of it, which is why I'm taking just 2. So it's 2 times x, which will be plus 2x. Then finally, let's multiply the same plus 2 times minus 3. So this will give us minus 6. Now remember that plus times minus is equal to minus, right? Okay, that is why this is minus 6. Okay, we have everything now, and then we equate it to 0. Next is to collect the like terms, which are these two. The middle terms are like because they both have x. So what we do now is to say x squared minus 3x plus 2x will give us minus x. And then minus 6 equal to 0. What we did just followed these steps shown down here. Therefore, the quadratic equation with the roots minus 2 and 3 is x squared minus x minus 6 equal to 0. Example 2. If the roots of a quadratic equation are minus 3 and minus 1 respectively, what is the quadratic equation from which these roots were obtained? First, we write down our roots, which are x equal to minus 3 and x equal to minus 1. Then we convert the solutions to factors. Remember, the solutions are the same thing as the roots in this case. So we convert them to factors. For x to be minus 3, it means that x plus 3 is equal to 0. Remember how we did the last one? In this case, we just added 3 to both sides. That will be our first factor. Also, for x to be minus 1, it means that x plus 1 is equal to 0. This will now be our second factor. Our step 2 now is to expand the factors x plus 3 and x plus 1 equal to 0. To expand that, we'll say x times x, which is this, and it gives us x squared. Next, x times 1, which is this, and it gives us x. Then 3 times x, which is this, it gives us 3x. And then 3 times 1, which is this, it gives us 3. When we collect like terms for the middle terms, which is x plus 3x, it will give us 4x. So we just write down what we got. And that will be x squared plus 4x plus 3. Therefore, the equation with the roots minus 3 and minus 1 is x squared plus 4x plus 3. Example 3. What is a quadratic equation from which the roots minus 4 and 3 are obtained from. Remember, write down the roots, which are x equal to minus 4 and x equal to 3. Next, convert the roots to factors. Therefore, our first factor will be x plus 4 equal to 0, and our second factor will be x minus 3 equal to 0. Next, let's expand the factors x plus 4 and x minus 3 equal to 0. When we do the expansion, we'll have x times x, which is this, which will be x squared. X times minus 3 will give me this, which is minus 3x. 4 times x, which is this, will give me 4x. And then lastly, 4 times minus 3, which is this, will give me minus 12. When we collect the like terms in the center, which are these two, we'll get x squared plus x minus 12. The reason for that is 4x minus 3x is equal to 1x, which we'll just write as x. That's why we have x squared plus x minus 12. Therefore, the quadratic equation that has the roots minus 4 and 3 is x squared plus x minus 12. Having solved those examples, we've come to the end of this class. But before we go, let us take a look at everything we've done so far. By converting the roots to factors and expanding the factors, we get back the original quadratic equation which the roots were obtained from. Also, negative roots form positive factors and positive roots form negative factors. For example, x equal to minus 3 would imply x plus 3 equal to 0, and x equal to 3 would imply x minus 3 equal to 0. Lastly, we know now that roots are gotten by solving quadratic equations or from quadratic graphs. Now let's try out some test questions. Question 1. Given that the roots of a quadratic equation are 1 and minus 5, what is the original equation? The correct option is B, which is x squared plus 4x minus 5. And how did we get this? Remember, the roots are x equal to 1 and x equal to minus 5. By making them factors, we have x minus 1 and then x plus 5. Both of them are equated to 0. By expansion, we have x squared, this times this, and then plus 5x, which is this times this, and then minus 1x, and lastly minus 5. By collecting like terms in the center, we have x squared now plus 4x minus 5, which is our option B. Question 2. Which of these quadratic equations produced this graph? The answer is option A. That is because from our graph, x is equal to minus 1 and x is equal to 2. When you carry out the expansion process, as we did earlier, you would find that the answer is A. Thank you for your time. I am sure you can now obtain quadratic equations from given roots. Till we see again, bye-bye.